Okay, so we're going to talk about measures of position. And the reason that we need to discuss this is if you are having something where you have two different scaling systems, like say the SAT versus the ACT, and you're doing something like a scholarship opportunity or an admittance type of thing, where you're saying I only want like the top 5% of scores, then you need to be able to say what that looks like on an SAT score, because that's going to be something maybe in like the 1500s versus in the ACT scores, that may be something like a 34. And because those are done on two different SATs out of like 1600, ACT is only out of like 36. So you got to be able to look and say, this is a top 5 score, but here's what that looks like numerically within the realm of that setup. Okay. So the first thing that we're going to talk about is what's called a Z-score, okay? So it asks, who is taller, a man that is 73 inches tall or a woman that's 68 inches tall? Well, I mean, obviously it's the guy, he's 73. But men are, by and large, taller than women as a standard statement, okay? So the next question is, who's taller by comparison to their gender? Okay, is a 73-inch man, which is 6'1"-ish, taller, would he be considered taller by comparison to other men than a 5'8" woman? Okay, so that is where we're going to bring in this thing called a Z-score. Okay, so the way that we find a Z-score is it tells me how many of those standard deviation chunks, okay, you are away from the mean. So for example, when we saw that bell curve in section 3.2, and we had a mean of 77 and that first spot up was at 85. That 85 is going to have a Z-score of 1 because it is one standard deviation above. Now, the value 69, which was below, would have a Z-score of -1. The negative indicates that it is below the mean, okay? But what the Z-score is going to allow us to do is I don't have to sit on 1, 2, or 3. I can now be at something like 1.27. or -2.38, something like that. So the formula is going to be X minus the mean over the standard deviation. Now, this can also be done using sample standard deviation and X bar, okay? So we're going to take a look at number 1, over here on our practice set. So it says a population has a mean of 10 and a standard deviation of 4. So it asks us to find the Z-score for a population of value of 0. So 0 is going to be my X. My mean is 10. My standard deviation is 4. So that's -10/4. Which is going to be -2.5. Now, when we're talking about this in terms of a bell curve, if there's my center, 1, 2, 3, that value is sitting right there. Okay, so it is 1, 2.5 below that centering line. Okay, now it says find the Z-score for a value of 11. So 11 minus 10/4. That's going to be 1/4, which is 0.25. And again, putting this in perspective up here, this would be right here. So it's about a quarter, or it is a quarter of the way between the middle and the first standard deviation. Okay. Now, for the third one, it asks us what number has a Z-score of 1.75. So in this case, we don't know the X, but we do know the rest, okay? So we're going to start by multiplying the 4 onto both sides, okay? And that's going to be 7 equals X minus 10. And then we're going to add the 10. So kind of just some real straightforward algebra here. And I get 17 equals X, okay? Now, let's also go over and take a look at number 4, okay? Okay, and this is actually that SAT, ACT type of setup that I was just discussing. Okay, so it says in a particular year on the ACT, the mean score was 24.5 and its standard deviation was 5.5. On the SAT, the mathematics mean was 545 with a standard deviation of 108. Okay. That says the distributions were approximately bell-shaped. So they ask us to find an ACT score of 15. Okay. So we're going to do 15 minus our mean over our standard deviation. And I get negative 1.727272 repeating. Okay. Now, for our ACT, they want us to do a score of 468. Okay. So for this one, now, on both of these, they are below the mean. Okay. So we anticipate that we will have a negative number. Okay. So I get negative 0.713. So it asks, on average, which one did the student do better on? Okay. Well, if I take a look on a pre-bell curve, 1, 2, 3, 1, 2, 3, in general positioning here, this one is about here. This one is about here. So we did better on the SAT, okay? Because comparatively, it was higher or closer to center than the other one was. Okay? Now, when we talk about Z-scores and the empirical rule, okay, going back and kind of putting those two things together, we have that the Z-scores for that 68% are going to be +1 and -1. For that 95, it's going to be -2 and +2. And for that all or almost all, it'll be -3 and +3. Okay, so we are able to now talk about these in terms of Z-scores as well as just the idea of what those percentages are.